Okay, I think this may be the one of the last mom reviews for the exam. This one is going to be super helpful, I hope. What it is essentially is it gives you different scenarios, and then essentially the point of this is to have a variety of different types of tests and intervals. And here's another one, and then can we correctly identify the right test? And then can we just um, use the calculator to get the statistic and the p-value? Okay, so it should be really good calculator practice. ID in the test and then calculator practice. So first one says that few people who receive questionnaires in the mail actually fill them out and return them, often fewer than 10%. I highlighted that right away because I'm like, well, it's a percent, so it's a proportion. So I'm pretty much already dialed into this one or this one. T's are for means, so I can just chop those two off. Um, Continuing on, one researcher thinks he can improve the response rate by including a coupon, good for a free pint of ice cream, along with the questionnaire. The researcher believes that people will want the ice cream and they'll feel guilty if they don't return the questionnaire. To test this conjecture, he mails questionnaires with ice cream coupons to how many people? 130 random people. And after 2 weeks, 36 people returned the questionnaire and ate their ice cream. We want to make a 95% confidence interval. So, is this a single sample or a double sample? And it all came from one large group, not two groups. Um, just one sample, size was 130. So this is, we're going to just run it on the calculator, okay? So, and we've got stat tests. We're looking for this. So naming it up really helpful, obviously. So that is um, lower down because I don't see it. There it is, capital A. One prop Z interval. 36 people returned it out of 130 people. We want 95%, just double checking, calculate, and there's my interval. And you will have, of course, your own values for your interval. Mine goes from 0.2 to 0.35. That'll do. Well, I'm not sure what to round to, but I'll let you guys wrestle with that. Okay, that's it for the first one. Number two, table shows the average number of points scored in a home and away game, in home and away games, by 8 randomly selected NFL teams during the 2002 season, over 20 years ago. Assume the offensive performances of these teams is representative of the other teams during this season and other seasons. Do these data provide evidence that of a home field advantage when it comes to scoring? Perform an appropriate test. Okay, well, they're all tests, so that doesn't really help. Um, is it a proportion or a mean? This is a question that you should just immediately go to over and over and over. And here it says AVE for average. So we are doing a mean, not a proportion. So you can cross off the two proportions. Um, okay. Does the data provide evidence of a home field advantage when it comes to scoring? Okay. This is kind of tricky. Is it a two sample t-test, a one sample t-test, or is it matched pairs? Do we have, well, let's see, this will help. What is our sample size? N is 8. What are the experimental units? This will help later when you're on FRQs, right? The experimental units are what? They are the 8 teams, okay? They are the ones that they're asking or recording data from. If you have an experimental unit that provides 2 data points, which is what's happening here, the Jets had a home score and an away score. Same thing with every team. If that is the case, it's a match pairs. Okay. Um, so now we're going to use the calculator. Now, when you actually carry out a match pairs, on the calculator, you actually run a t-test on what? On the difference in the lists. Okay, so I'm going to put this into L1 and this into L2, and then I'm going to get an L3, which will be the difference between them. Okay, so this will take a little bit of time, obviously, and of course, it is ripe with the opportunity to make a mistake. So 24.3, boop. You can obviously skip this if you feel like you know what you're doing. Fast forward the video, whatever you got to do. Oh, geez. 25.2, 18.9. I was just feeling like I should have music playing. I'm getting bored already. All right, I'm going to double check. Well, heck, I don't have to type it in. I'm not going to double check. You can do that. Okay, so then list 3 is going to be the difference between home and away. I'm going to say home field advantage, right? They're asking me right here, is there home field advantage? So I'm going to do home minus away. So that's list 2 minus list 1. Sorry, that's 1 minus 2. List 1 minus list 2, and then boop, there's the differences. Okay, and let me think here. I'm going to get my test statistic. So I'm going to run like I said, a t-test on the differences in the lists, which is L3. So stat tests, this is number 2. I'm going to well, I could say data. I have the data in list 3. The null is 0, okay? Let me jot down my null and alternative. The null would be that the average difference from home minus away is nothing. There is no difference. There is no advantage. And the alternative that we're checking, you have to read. It says, is there evidence of a home field advantage? Which logically means when you're a home team, you score more than when you're the away team. So I'm going to say that if there is an advantage, this difference would be 0 because I subtracted, remember I did home minus away. Home minus away would be greater than 0 if there is an advantage. So the null, mu0, is 0 because that's the null. Then list 3 is where I had the differences, and then I choose greater than and calculate. So my test statistic, you probably have a drop down there, huh? This would be a T7 or a T. It's not a Z. And it's a 7 because there's degrees of freedom is 8 minus 1, which is 7. And my test statistic is 1.0887. I'm not, one decimal place. So mine would be 1.1. My p-value would be 0.16. Okay, so I know it doesn't ask me for a conclusion, but with this p-value, that is above 0.05. So this actually says or suggests that there's not enough evidence to say that there is a home field advantage. Number 3, a National Cancer Institute published a study in 1991. They examined the incidence in cancer of dogs. Of 827 dogs whose owners used weed killer in the yard, I'm guessing in the grass on their lawns. So in this sample, 473 had cancer. Then they came back and they had another sample. 19 of the 130 dogs that had not been exposed to herbicide had cancer. So we have two samples, okay? We've got P1, which is a proportion, 473 out of 827 that had cancer. Maybe I'll do this. PW, P weed killer. Those are the dogs that lived in the house that used weed killer. The red one would be PN. How about for no weed killer? Um, that was a smaller sample size, and those were the results. So you can tell just by starting to kind of write out what we have here that it's a two sample proportion, okay? Because it's percents. If you are curious, like I am, before I even run this test, or oh, I'm not doing a test, I'm doing an interval. I'm just curious, like what are these two percentages? This one is 57%. And the other one, this is the houses that did not use weed killer. They had about, if I round that, 15%. So it looks like a pretty big difference. All right. Now I'm gonna do a interval. So two prop Z interval, down, right there. B. Um, Now, let's see. I believe whatever I put on the top, so if I put weed killer on the top, 473 and 827, then it's going to do weed killer minus no weed killer for my interval, meaning it's doing P PW minus PN. And I was looking for a context clue in the direction that if is it asking you to subtract a certain way, like weed killer minus no weed killer or vice versa. It just says an interval for the difference in pets' cancer risk. So I'm hoping that even if you switch this, meaning if you switched sample one and sample two here, that you'd be fine. And we have 95% confidence, calculate. So we are 95% confidence that the difference in the rate is between 35% and 49%. Oh, that would actually round to 50. I don't know how many decimals you need, so good luck with that, but there you go. Number 4. An agronomist hopes that a new fertilizer she's developed will enable grape growers to increase the yield of each grapevine by more than 5 pounds. To test this, she applied it to 44 vines and used the traditional growing strategies on 47 other vines. So it looks to me right away like I have two samples. This would be sample 1. This was with the fertilizer, right? She applied it to 44 vines. So that would be like sample size 1. And then she came back and she used traditional methods on 47 other vines. So that would be sample 2 and 2. So I have two samples right away. So I'm going to cross off that one, cross off a 1T test as well. Okay. It's not matched pairs because I didn't have one vine contributing two values. A vine either got the fertilizer or it did not. Every vine contributed one value, so it's not matched pairs. The fertilized vines produced an average. Oh my gosh, there it is. It's a mean. So I can cross off that one, and there we go. So it's a two sample T test. Fertilized vines had a mean, I'll stay color cone. The fertilized ones are the green ones. Had a mean of 58.4 and a standard deviation of 3.7. Meanwhile, the unfertilized vines had a mean, an average of 52, and a standard deviation of 3.4. Does it confirm the agronomist expectations? So let's do the test on the calculator and find out. Stat tests. This is a two sample T test. Number 4. We're going to do the stats because we don't have all the data in our lists, right? Put the green numbers first. The average for the fertilized vines was 44. Oh, sorry, that was the sample size. I should be looking here. This was the average of the fertilized. And the standard deviation was 3.7. And that was 44 vines. The second sample in red had an average of 52.1, 3.4 for the standard deviation, and that was 47. Now, what here? Which direction is this test? I'm going to have to read one more time. Look for what they hope or believe. They hope that the fertilizer will enable grape growers to increase the yield. There's the ticket. So the ones that are fertilized, the green ones, she's hoping they are bigger than they produce more grapes than the red. And the green is the first sample, okay? So if I have mu1 is the fertilized, the average of that group. Maybe I could, if you want, the average of those 44 should be greater than the average of the 47 that did not receive fertilizer. Um, so that I've already got that. Okay, so mu1 is greater than mu2. Pool, don't pool ever, and calculate. Test statistic. Um, I'm not exactly sure what is given to you, but it's a T. It's a T, and I would say T43. Why 43? I'm taking the smaller sample size. I don't even know if this is required of you on the mom, which was 44 minus 1, so 43. It's a T distribution with 43 degrees of freedom and 8.44. So that's a massive statistic, and the p-value, well, look, 3 times 10 to the negative 13. That's 0. So I'm guessing you're going to have to put like 0.0 if you have data similar to mine. All right, number 5. An insurance company advertises that 90% of their claims are settled within 30 days. Right away, I see a percentage, so I'm pretty sure it's a proportion. So let's cross off what it's not. It is not a t-test. It is not a t-test. It is not a t-test. So it's either a single sample or a two sample proportion. What happened next? A consumer group randomly picked 104 of last year's claims and finds that only 89 of them were settled in 30 days. So it looks like they only collected one single sample. It looks to me like they had their sample, their p-hat, was 104 random claims right there. Of those claims, only 89 of them were settled within 30 days. So this is a single sample, okay? There is the company guilty of false advertising. So this will help me as I look at the null and the alternative because I'm running a test. The null is what they're claiming. They are advertising 90% settlements. So they're claiming that their proportion that are settled within 30 days is 90%. The alternative, if they are false advertising, which way would that be? Would that be less than or greater than? Well, nobody would complain about the company if they settled more than 90%. They would only be upset if it was less than 90%. False advertising leads me to a less than there. So let's use the test button. Stat tests. One prop Z test. Number 5. P null, that's the null, 90%. X is the 89 claims that were settled within 90 days out of 104. Make sure you do less than. Calculate. test statistic. This is a z-test. So this is a z-score. Negative 1.50. P-value is, whoa, so close, 6. It doesn't ask you to make a conclusion, but they are very, very close to the 5% level of significance. They're okay. They didn't go below 5%, the company that is. So we would fail to reject this. There's not enough data to support this, is what we would say. Number 6. Some cigarettes sold in the US claim to be low tar. How much less tar would a smoker get by smoking low tar brands instead of regular brands? Regular cigarettes. Samples of 15 brands of each type were randomly chosen from 1,266 varieties. No kidding. Oh my gosh, that's how many kinds of cigarettes there are. Their tar contents, milligrams, are listed in the table below. Oops, I don't have a table. Find a 95% confidence interval for the difference between regular and low tar brands. Let me do this. Let me go find a table in Schoology. I'm not sure why the table did not come with. This will just be a minute. Here we go. Let's just grab that one. Sorry, you can fast forward to when I'm done with this. All right. All right, got my data. All right. And these are not proportions. I see no percentages, so there's no proportions going on. So was this from a 1 sample or a 2 sample? And it's pretty clear that your first sample is regular and your second sample is low tar. So it is a 2 sample, not just a regular 1. Now we are doing an interval, okay, for the difference for regular and low. So this is the point again where you would have to take time, probably pause the video again. You need to enter the data in the calculator. I'll go back and clear out my lists here in list 1 and list 2 and take my time and enter them in. I'm going to do low tar, or sorry, I'm doing regular in list 1, L1, and low tar in list 2. Remember, this kind of data entry is highly uncommon on the exam. If they do have you doing data entry, it's not nearly this many data points. Okay, back to my low tar, 9, 5. I can see as I'm entering these that the low tar values are all much lower than the list above it. So just at first glance, I think it's going to be significant, but what do I know? All right, I think I've done that well, but I don't have to type it into the bottom, so I'm just going to roll with it. Create a confidence interval. So here we go. 2 sample T. Oopsie. What did I just do? Yikes. Stat tests. I want to go 2 sample T interval. There it is. 0. Okay. And I have the data. So I'm going to click that. List 1 and list 2 is where I put it. Leave frequency is at 1, and we're doing a 95% confidence. Don't pool and calculate. So the difference I have is right there, 4.31 to 7.95. 2 decimals each, it says. So we're 95% confident that the difference in tar in cigarettes, if you do regular cigarettes, regular minus low tar, the difference between that is, we're 95% confident it's between 4.31 micrograms per cigarette and 7.95 micrograms per cigarette. Number 4. No, 7. I saw 4 points. Wegmans, a food market chain, developed a new store brand brownie mix. Before they started selling them, they wanted to compare how well people like their brownies to the brownies made from a popular national brand. Okay, in order to see if there was a difference in opinion, Wegmans asked 124 shoppers to participate in a taste test. Each was given a brownie to try. Subjects were not told what kind of brownie they got. That was determined randomly. 58% of the 62 shoppers who tasted Wegman brownie said they would liked it well enough to buy it, compared to 66% of the other 62 people said they would be willing to buy the national brand. Okay, well, I see percentages. So first off, it's not a t-test, okay? And it's not a matched pairs t-test. So was this a single sample or a double sample? This is a little bit tricky. So we had a total N of 124, but if you dig deeper, it is two samples, because here we have the first sample. They randomly picked some of them to get Wegmans brownies. So that sample was 62. N1 is 62. The proportion for the first sample, when we say Wegmans, how about the number of people that got the Wegmans brownie? Of those 62, 58% said they would like it and they would buy it again. So I need to I want to know that number. What is 58% of 62? I'm pretty much doing N times P. 58% times 62. And 30, I'm going to round that up because it's got to be a whole person. 36 people said they would buy it again. Then the national brand is the other brand, right? That would be 66% of the other 62 people would buy the national brand. So that sample size, we'll say N for national, that was 62 people as well. And the proportion of the national brand that would buy it again was 66%. So I need to get 66% of 62. And again, round that to a whole number because that's people. So there's my two samples. Okay, put that in there and we'll get a test statistic. Well, I should slow it down. So pretty obvious from this, it's two samples, the national brand and the Wegmans brand, not a single sample. Test statistic. 2 prop Z test, that's number 6. X1, let's do Wegmans first. 62. Sample 2, 41 people said they would buy the national brand. All right, now is this a less than, not equal to, what are we doing here? Oh, here we go. We got to read. Does this result indicate the consumer interest in Wegmans mix is lower than the national brand? So the null, if you'd like to think about the setup, the null is that Wegmans equals the proportion for the national brand. The alternative would be that Wegmans is lower, less than the national brand, which just seems logical because this is lower than this. But there, okay, I guess I had it selected already. Calculate it. My Z star is my statistic. That's my Z, and it's negative 0.93 to 2 decimals. My p-value is 0.18. So it turned out to not be significant because this is above 0.05, which is what we were using. Okay, is this the last one? Hallelujah. Waiters are expected to keep track of their income from tips and report it on their income tax. I wonder how many do that. The IRS suspects that one waiter, we'll call him Jared, has been underreporting his income, so they're auditing his taxes. An IRS agent goes through the restaurant's files, and obtains a random sample of 80 credit card receipts from people that Jared served. The average, here we go, average, okay? So it's not a proportion, it's a mean. So not a proportion, not a proportion, okay? And we had 80 credit card receipts. The average tip size shown on the receipts was $9.68, and the standard deviation, so average was here, standard deviation was here. Make a 90% interval. This is a single sample, folks. It's just we we have one group of 80 receipts. Okay, 80 receipts. It's not two. All right, let's plug it in the calculator. We're just making an interval, so I don't need to think about my hypotheses. Stat tests. This is a t-interval. Stats. The average from the 80 receipts was $9.68. Standard deviation was 272. N is 80 receipts. We're doing 90% for me. I don't know what yours is. Calculate. Okay. And so now they know that they're 90% confident his average tip was between $9.17 and $10.19 if you round to the nearest penny. They're 90% confident that his average tip received on a meal is between $9.17 and $10.19. All right, folks, thank you. I hope that helped because it kind of covered all the tests and intervals. See you.